lots of students. Naturally, you are loaded full of knowledge. That means short week and back to home in a new idea. I try continue my previous lecture focused on energy storage, and I would like also convey nice information that one of participants has after exam delivered a small talk about harvesting mechanical energy. I only record here only his speech, but she prepared a nice short presentation, and it will be as additional information regarding energy harvesting and storage in different forms. Which I told you that it is such a similar system working in Germany, because in south east part of Germany is a special scientific town. There is nearly central from facility. It's a many interesting institution and scientific and research and development center. It is so-called best center in Germany. When you write in internet best tools or Helmholtz Center, you find that participate. It's also interesting, but very open for collaboration of all world scientists, especially young or on field stage of career person from our work. It is a very good place for doing science and influence.
I perform several projects and find good collaborators. Is also recommended to check a website of Helmholtz Centrum and find for your interesting places. Also, it's many announcements regarding call for collaborators to the position, especially not only research but also research, because it is connection between industry, is bridge between industry and science. We start from more. And I also would like to talk you some about different when there is lecture storage solution. Is one is hydrogen storage, thermal energy storage, compressor-based storage, mechanical energy storage, and many difficult. I don't know how I'm able to explain you. This one of proposal. It is harvesting and storage magnetic energy. It is interesting because such idea was developed in end of 80 years past century, when was discovered so-called high temperature superconductivity. But unfortunately, critical temperature was very low because, for example, when ever materials possess 50 Kelvin critical temperature, when we are in, it is a critical temperature, when we should go down to obtain opportunity to not destroying superconductivity by external magnetic field. It is a great challenge because available for application
not working properly, especially because it is a ceramic material. And such idea seems excellent, but needs some introduction by physics. You remember from school how you can storage magnetic energy in solenoid. Right? It is some formula. It is the density of magnetic energy. Here is
perform integration about volume of such solenoid, and in next step we can obtain a formula for energy storage if it is an energy stored in particular solenoid. This was an idea to utilizing advantages of superconductor when it is electric current not decreasing his power to resistance. It is almost not very efficient. It is a very efficient system because we charge and storage. Nobody decreasing energy because in ordinary system we should supply electric power because change some energy to resistance exchange into heat. But in this such idea, we have a solenoid. It is solenoid is embedded in a cryogenic refrigerator, and we need helium, liquid helium or liquid nitrogen to cooling system, and only one kind of energy is needed for harvesting such energy or storage. It is expenses for cooling system, and probably you know that
below liquid nitrogen is very expensive, extremely expensive. But idea when we have superconductivity in room temperature and is not necessary cooling, it was very promising and exciting. But now I think it is a little bit problem, but for particular application, such storage system working okay, especially in laboratories. I show you practical solution. You know that it's necessary to overcome technological problems. For example, one wire for one solenoid is sometimes long for 1 kilometer. And we have calculate that it is necessary to change geometry of that material. This ceramic
for application, but we can obtain some good results. Here is information regarding problems connected with cooling to appropriate temperature and energy required for keeping a system in extremely low temperature. It is one of disadvantages, but such phenomena was investigated in many laboratories, and I show you in next slide how many countries were involved in such program. And it was a surprise for me when I found that after Polish attempt to storage magnetic energy, Indian scientists also do it. And so I think that it is important from such storage systems are important from fundamental point of view. You know that in India is many institutions and with private funds, Tata Institute for Fundamental Science in Mumbai, where is the lowest temperature in the world. It is some really it is a big challenge to grow to lowering temperature below liquid nitrogen, liquid helium temperature. And what is the advantages of such system? Only few, and when it's working properly, when we have a superconductor with need to cool it, it will be very interesting because fast response system able to back energy very fast. High power density is connected with high intensity of current, miniaturization and long service life. It is not moving parts. And it is interesting. Low environmental pollution, when we not, it's not obligatory to cooling, it was a very nice system. But some disadvantages, as I thought, high material cost. It is not only equipment, not a system for keeping solenoid in very low temperature, but in comparison to another equipment and method of energy storage, it is low energy density. And also some problems with application, because it is not interesting from practical point of view, except especially scientific investigation. And I should shortly go across one extraordinary and still actual topic in science. It is storage energy by electrochemical phenomena, electrochemical phenomena. You know that the problem of batteries is very important. Our mobile phones, our cars, the sun, another system for energy storage based on electrochemical origin is very important. And although it is very old problem, because at least lead acid batteries were discovered in 1955, and it was unfortunately very disadvantages. It is, for example, hazardous acid leaked, and another they still using, especially in cars, for stark batteries. Most typical batteries in cars we are working in such 100 more 50 years old assist. And it was many advantages for improving batteries, especially based on the same formula. And most important were, for example, nickel cadmium cell. Cadmium is also hazardous materials and bring some problems with utilization. And some breakthrough points was in the last century when lithium batteries were discovered and the so-called nickel metal hydride batteries in ATMs. It was necessary to overcome some problems with stability with such batteries, with mechanical stability and other problems. As such, battery working in very simple way. When we charging, we have unbalanced stored electrons and holes, and after join to receiver, we can charge such battery. It is not easy to charging such battery again, but when we try to charge such chemical batteries, we know that it needs a long time technique. It is such batteries also improved. There were some progress in electric materials and so-called materials with high electric permittivity and flexible conductor and some technology of deposition of ultra-thin film. It is agreed advantages of such nowadays when we can apply a new preparation technology in old solution. And also some batteries with solid electrolyte were improved and improved to practical application, and as such batteries possess a strong output in comparison to previous solution and are more environmentally friendly. And one problem of such new batteries is connected with the availability of some elements, especially I mentioned such a problem early when we discussed about some rare earth elements for life. It's a great problem because, as we thought, only few places in the world, some countries possess mining when it is possible to preparing clean lithium for energy storage. And it is also human activity focused on two topics. One topic, eliminate lithium, and second topic, change may be a different solution for green for green energy production. Because, for example, car, because we know that typical batteries is a few hundred kilograms in cars, depending. We have a little bit car, and not a small, it is a 400, 500 kilograms. It is a strange problem because it is a problem with inertia. When such cars start or stopping, it is you can understand such idea when maybe a typical with traditional fuel tank, it is a 50 kilograms. But battery for HANA and different 350. How much person you can have the car to balance a weight? And 5 person. Okay, and second problem connected with not only weight but also recoverability of lithium, focused the scientists to make or put attention on more accessible element. When you look for Mendeleev table, you see that a neighbor of lithium is sodium, like and A. And as some attempt to prepare sodium sulfur battery was explored many years. And when I have a very good collaboration with a Taiwan scientist, and you know that Taiwan is technology in top of world. It is, for example, it is a very strategic problem with processors. Yes, it is some conflict between his bigger neighbor. Also focusing people for find a different solution. And when we start a project focused on light for wildlife, we complete preparing a few articles focused on sodium-based batteries, because the industry and government change funds or move funds from lithium into alternative source of chemical storage system. And unfortunately, when you see for a specific capacity of both systems, it is a lithium and sodium, it is not a quite challenge, yes, and up to present, sulfur batteries do not possess concurrence in the lithium batteries density of energy, because it is a big problem for, especially for mobile application, because when you have to time however more heavy your mobile phone or car have a battery not 400 kilograms, but 800 is a little bit problem. But for storage energy in stationary application, for example, in houses, in storage energy in farm, photovoltaic farm, it's give some fields of possible application when we are focused not on coefficient energy to mass, storage energy to mass, but storage energy to price. It is from economical point of view very important, because as I told you, you have a battery which is very expensive, for example, $5,000, which weight is 1 ton, and second battery, for example, 5 times cheaper, but 3 ton heavy. It is no problem that it is stored in our garden. And it is such batteries may be also utilized in some popular application, like in cars. It is very important when we have, for example, not big battery, because when we focus on so-called semi-electric cars, it's hybrid electric car. We harness it for storage, part of mechanical energy, when we, for example, decreasing speed. Yes, but what it is also interesting that scientists, together with people from industry and from economic, show some key points or key problems which will be necessary to solve to over disadvantages of not not lithium batteries. It is some problems, because promising idea to preparing or fully electric car with cheap and light battery, it is great advantages. As example, I can you talk that in our country, you know, Poland is a north and the sun is not so intensive like India. It is some information that people which working, for example, 500 kilometers, no, 50 kilometers from center of town, because like in India, in town, in houses is expensive, of center is more cheap. And people preparing or set up solar installation, and one thought that during 3 years he not buy money for food, because he buy not so expensive electric car with range 200 kilometers, which is not a big challenge. And when came to home, switch to solar cells and have a free energy. It is a very good idea, because, for example, when we able to charge our car with energy, for example, 10 kilowatts, we charge a small car in 4 hours to drive 200 kilometers. It is not so difficult, because, for example, when you came home, back home in evening, sun starts at 3 in the morning, and up to 8, 9 o'clock when we depart, it is maybe fully occupied. Okay. This I expressed just one way, and because I have some disadvantages. Slide not really possible. Okay. this will be in current quarter. Just moment, I move to go to next. And we have a comparison, some different system storage of electrical area. And depend of possible application, we can use some different methods for capacitors. You know, this extremely fast charge, extremely fast the charge. Electrochemical capacitors is the process density of energy significantly higher. But when you see, when we go to a specific energy, a specific power decrease, it is a great disadvantage. But also, when you see on such lifetime of batteries and capacitors, you see that capacitors is almost without maintenance working several years, but with batteries is a big problem. And no no any company which sold electric vehicle not told you, but when you charging your car very fast with high energy, such city replace. And now we know have the problems with batteries because such electric vehicle not working for a long time when such cars pass longer distance and sometimes maybe mechanical destruction of such batteries. There's such some problems with situation when this car accident. We also should predict what's happening. And after some unexpected short circuit in some garage, and when the car started fire, it was a big problem because maybe no suffered of utilizing a card which we can exchange gasoline into gas, liquid gas, is a more suffered in opposite to electric cars. In many underground parkings, this is forbidden for electric cars because it's a problem how what to do when it start short circuit. It is many, for example, there were some small accident, etc., or maybe internal problem. It is a great disadvantages and also opportunity to find a new solution. Okay, we can continue our talk because we have 54 minutes to end, and we will speak about green energy, but from the different point of view. And I found such information. It is like when some such equipment exists. It is only some advantages. It is low to zero emission, high efficiency, reliability, fuel flexibility, energy security, durability, scalability, and quick information operation. Scalability is connected when we have a device, when we need more energy, we can very simply explain or will be the same only bigger, but what will be the same. I think that it is impossible, but it's some idea. It's about fuel cells, and it is a special device which burns hydrogen. And when we burn hydrogen, we, as pollution, obtain water. And it is a very simple, physical phenomena which is such application or devices because we need put hydrogen and take oxygen from air, and as a result we have a very safe, safety and controlled fuel for green energy. And maybe we go to next slide where it is overview of overall view of such equipment, and it seems very good because as we see, we need only source of hydrogen. For example, when we have a source of hydrogen, we able to utilize it as energy without any pollution. That's very good because, for example, when here will be output to engine in electric cars, so we have one of methodology of or way to go to more green trend. And it was interesting that this exists in different forms. And some form of fuel cells is for a particular application and for particular source of hydrogen, and also for weight and energy problem. Because such fuel cells working in the same principle, but some different process of extracting dividing hydrogen into proton and electron. Because some problem which arise in such devices is connected with separation, because it's necessary to have a very good system for fields dividing hydrogen for two It is electron and proton. Because it's not so difficult. Because no, but when we have electron and we make when we try to consider what is the difference when electron weight will be 1 kilogram and proton 1 ton 864 kilograms. It is a big difference between both particles. When we expand proton to 1 meter, orbit will be almost 12 kilometers. It is not so difficult to separate both. And ionization of hydrogen. And it is a principle of such system. But it is not so new system because a Greek problem with some electrodes, a cathode and anodes, when separate such particles. You know that hydrogen is a great challenge for find solution. But do some technologies, improving technologies, we can preparing a big system for producing energy in industry volume. I think it's not so fresh idea because, as you see, such an idea 60 years ago was discovered, and for example was first vehicle, not motorcycle, utilizing such source of energy. And second is also, second and third is important to understand, because for space science and exploration and for military, it was important, not expenses, but functionality. And such topics, or not topics, but a way for solve some problems give huge money for science, which give opportunity to improve technology. And also, in 50 years ago, this was some buses for utilizing fuel cells. And some problem is for producing or manufacturing electrodes. It is many attempts how preparing porous materials, how preparing composite materials to divide hydrogen for the proton and now new discoveries in material science like 2D materials starting from graphite and another which we discuss which we speaking about supercapacitors also were employed into improving cathode and anode system which separate such neutrons. And it is also important that we can preparing a more efficient system cathode and anode, which giving higher durability and decreasing cost of production, and also caused that some devices will be more useful, need less maintenance, and maybe more cheaper. And it is some mistake was with the slide. And also strong and the best laboratories in the world try to improve membrane for proton exchange for fuel cells. And it was recently published in Nature one way for grown electrodes which for functionality is focused on divide two nucleus from hydrogen. We can opportunity to very fastly and with good durability utilizing such material for anode and cathode to have a very good yields output from such equipment. It's also interesting how idea which was proposed 60 years ago, back when we have some progress in material science, especially in nanotechnology, because without a full pilot investigation of structure phenomena, we're not able to do no. But here is, I think it will be one of most important device for producing locally electrical energy with a fully green procedure. But one problem arises. From we able to take time. When we look for map, we see sea, water. But how divide both for oxygen and hydrogen? Because next, when we have a separate, we can use in fuel cells. We discussed previously in 2 days ago about water splitting. But as we know, water splitting we sometimes not only excellent electrodes, but also sometimes when we have electrochemical method, we need electrical energy. Electrical energy, green energy, we can obtain from solar cells, for example. And when we have solar cells, which may be locally charged by devices for water separation, and next problem arises. From explosive point of view, hydrogen is very dangerous because in air it very fastly make reactions, exothermic reaction, and give much energy. It is maybe a great problem. And how we should solve as a problem with storage. And it will be in next part of my talk. Now we have some quite fresh information regarding CO2 because it is a great problem. And some weather anomaly when you see yesterday and 2 days ago, and some anomalies in north of Poland when climate change. During our discussion, I told you when I was in your age, temperature below zero start at end of October, and snow start melting in March. But now we one day have -5, the second day +15. It was some anomalies, and you see with global thermal effect. And it is also connected with our atmosphere, because atmosphere is important from different point of view. One point of view is connected with our particles. When we have many gas pollution, which able to monitor using legal system, as we discussed. It is some new illness appearance in the population. It is a great problem. The second problem with decreasing or changing gas content in atmosphere. So-called ozone shell, which are preventing UV. Also, maybe for photovoltaics is very good, but for our skin it's not, because when we not have a screener by some shell in atmosphere against UV, we can maybe have a problem with cancer of skin, but also with decreasing some breathing system. And for such, we discuss only up to present few technology. We discussed about magnetic system, we discussed electrochemical system, about not discuss about hyper system, we not discuss about pneumatic system, mechanical system. Will be involved in such and thermal system. It's a method which we can combine to improving our air and our water by decreasing CO2 and heat as most important pollution in nowadays. And here we have some guidelines towards applying a particular method of storage system. And we have different systems. And when we, for example, try to utilizing a particular system, we should choose advantages and disadvantages of each solution. Because, for example, in Siberia, utilizing hydral energy, it will be not good, because the temperature is or 4,000 centigrade below zero, so water utilizing it is not good. And for example, in your country, also when some exploration is very strong, we have some problems with utilizing some phenomena, some systems. And for example, when we think about a range of electric car, what happened in India? We should switch on air conditioning in energy. This doesn't make sense. When I try to drive the car in winter, I use much energy for heating because it is not a combustion engine when we can use some energy. There's also some additional problems which we should take account when we producing some new technological equipment. For example, I not show depends of the capacity of battery in low temperature. And it is a big problem because in North countries, when winter starts, the problem with start car because battery volume decreasing in natural way when it's temperature minus 10, minus 15, maybe less than 50% of original volume in room temperature. There's some problems which is connected also with a storage battery, because when we have outside batteries for solar cells, and we have some disadvantages. In the winter, sun is radiation sun is much lower at much lower level in compared to summer, and angle of incident is also changing, and also volume of batteries when it's not stored in warm place also decrease. We have some problems, local problems, which we should solve. And we try go to next system of energy storage. It is storage of mechanical energy. And when we try to stop on car, there's friction on disc and blocks. And we exchange mechanical energy into heat. But in an electric or hybrid vehicle, we can back such energy do a charging our system when we are able to use such car properly. It is a sound system, but for example, when we make some very simple experiment, we see that energy with rotating disc is also quite big, because it is connected with moment of inertia and angular factors. Yes, it is like kinetic energy, but we exchange mass for momentum of internal momentum and velocity by angular velocity. Yes, with a frequency. And it is connected. And for example, we have a 3 or 5 ton disk which rotating. It is quite big energy, but it is also decreasing of such energy in time is connected with only friction. When we eliminate friction, using, for example, some magnetic system or if you have a special connection with a small friction, we can do it. For example, when we have an energy stored in rotating disk, when we need, we put connection with a generator and make electricity. Maybe what will be the source of input energy for charging a subsystem? Maybe electrical engine, which we, for example, utilizing sun photovoltaic. And when in day we can improve rotation speed of such a system. At night, we will be try to back utilizing, for example, electrical generator. It is one of solution how to go here. And now we can back to hydrogen. When we back to hydrogen, we see that it is some important milestone for development energy was that was 50 years ago, because some proposals were established some direction for utilizing energy from hydrogen, green energy. And it was one attempt, it was utilizing hydrogen as a fuel for cars and trucks, and for example for train. And next was a significant development in material science, which give opportunity to construct a more efficient and stable electrode for fuel cells. And in the start of such century, first commercial fuel cell vehicle was introduced. It was first time you can buy a vehicle which fuel is fuel, hydrogen fuel is applied. It is, for me, it will be a great problem, because in Poland we have one fuel station with hydrogen, and closer from me, a second, to say 500 kilometers in Berlin. And I was picked up my car on hydrogen, on different car to plug by hydrogen. And in many countries, especially countries with when a problem of pollution, especially transport source pollution appear, it is especially in small countries in Europe, like Poland, Belgium, etc., when people have a problem, and especially when town is located in the valley, when the smoke is very strong and badly influence on human life. And many countries place and hydrogen strategy. This was what we can help to solve a problem. On when we have some cars on project now, two years in European community is a call for project focused on hydrogen or green energy for green production of hydrogen. And the second problem for find solution of separate storage such materials. And here you can see work map with countries which interested to utilizing green energy, especially green energy from hydrogen, production of hydrogen. And small Europe, because all Europe population is less than your country, and for your because we should sometimes discuss about scale. For example, small European countries like Lithuania, like Latvia, like Estonia, three countries. The total population is less than 5 million people. It is a small town in India. And population Poland, Germany, and some small countries is less than Bangladesh. That would be equivalent. Yes. It is a problem because maybe it is old map because it is a map 3 or 4 years ago. But now also in India is a government of India also is focused on green energy because if you see you can have some advantages with general energy. Each energy was needed to grow such a huge country, but now it is also when it is an economic problem, also your country is interested to grow or preparing green energy. Here we have some source of method of producing green energy, and they go here. And most important is highlighted in violet because it is very fast and most efficient and eco-friendly technology. It is connected with photoconvection. It is photoconvection. I think it is water splitting electrochemical, but only but also without energy. Electrical energy only utilizing radiation. It is very important because we not generate in such a system additional heat. Another method, a little bit more complicated. That's when we use wind, hydro, or utilizing geothermal energy. It is we need also use such energy in turbine generator, like electrolyzer, and finally we obtain hydrogen, which we can use to produce electricity utilizing fuel cells. And maybe we sometimes discuss such problem because solar cells produce electricity directly. But what for we try to make a longer way because solar produces energy and finally we obtain hydrogen which we need for preparing for exchange into current. Because, for example, we have overload of energy, sun energy in particular periods, particular place, because when we make a farm of photovoltaic far away from living center, we should storage such electricity. It's more easy storage electricity in form of more complicated system like this hydrogen when preparing or buying battery system, electrochemical battery system. It is many attempts how solve such problem. And when we go to chemistry, we see some properties of hydrogen. Unfortunately, when we like to make storage hydrogen in liquid and solid form, it is extremely expensive because we should cooling. Cooling to high low temperature is very problematic and from economical point of view not interesting. But what is interesting when we able to storage hydrogen in medium pressure, in gas form, compressor, but in gas form. But maybe such table is very interesting, especially a second. You can see some comparison properties as well hydrogen and another form of energy utilized for example in the combustion system. Yes, when we able to see air ratio and energy, hydrogen is the best when we consider a coefficient like energy collected in 1 kilogram. For example, 1 kilo of hydrogen, it is equivalent energy like more than 4 kilo of diesel. It is some advantages. How, and for example, when we burn diesel engine, we produce a huge CO2 and some different pollution. But when we utilize in the same system hydrogen, we have opportunity to consider if a clean water is a pollution. It is some kind of problem to solve. It's a problem, most difficult problem to collect such energy in form of pollution. But now we can discuss topics connected with production of CO. Some results which will be presented in the next slide is unexpected, but it is unfortunate. And especially in countries like your country and some countries when is agriculture is very strong and some pollution connected with cultivation of animals is also is a problem. It's interesting some biotechnologies able opportunity to exchange such pollution into food. And I not include some method of producing and source of biomaterials which use for production of hydrogen because you are before lunch. And some technology is well established and now many groups are working on improving the technology and optimization process. But it is important that the result is very promising. And for example, here we have some information regarding hydrogen production. And it is some information regarding applied biotechnology. And you know that during fermentation you can produce, for example, methane gas and other, but here is also possible to produce such gases. And next slide is with green hydrogen production. And you see that during 15 last year, volume of produced hydrogen using green source increased from 1% up to 17%. But we may be proud 17%, but 83% is non-green energy. But also, is some countries which focus on producing green energy. German people have a big problem with so-called old industry, especially was focused on coal mining. It was a very strong element of production in Germany. It was a source of energy. At first, they changed coal on atomic plant, nuclear plant, and now is many problems in energy with the storage of pollution. And after Fukuyama, Chernobyl, and another, people applied, and now it's a collapse. And they focused on producing green energy, solar cells, and hydrogen. But a such slide, when I preparing all my lecture for you, was very surprising for me. To producing and utilizing a green hydrogen, you or we must be rich person. Because is here. Production cost of hydrogen in the lower slide, but in the same scale, green hydrogen production cost. And you see, it is between 4 in Germany dollars per kilogram up to $9 in USA. But now maybe more expensive. There were some commercials in the US. And here, in the right side, you have information of in which application we can apply hydrogen. It is some interesting area because hydrogen is not only utilized for as a fuel, but also in important chemical components for chemistry. And now we go slowly to end of my talk, maybe around the time. It is a problem with storage produced hydrogen. And there are some new, maybe from first look, controversial method. It's working and it's very interesting because when we storage coal or we storage liquid fuels, it's not so great problem. Only problem with environment protection. But some proposals connected with storing hydrogen have a source in geology, because some salt meaning not using steel and empty flames carried underground may be used as a big storage system for hydrogen. Such technology is applied because it is need any shells in summer. Because salt is not transparent for hydrogen. It is a great problem for not great problem, but it is very good information. But it is generally storage of hydrogen in gas form is very difficult because hydrogen pass across a glass, across metal, and it is a problem. But here is storage in very good way. Here we have some opportunities we get to see some place when is it possible to storage gas hydrogen in gas form in such very salt wind. Because I see India is also possible. What is a stage? Is a delta or not? You will see here. It's also in your country. It's possible storage of hydrogen in such form. And except a storage system, we need a transport system, because a system for energy producing, for example, using fuel cells, is connected with the transportation. And I think when such electric factories should be located close source of storage. Yeah? problems when the place is stored in should be. It is also connected uh, if, with the problem of transport electric energy. But while we discussed it is problematic because it's necessary to build such wide transport line. But second, we have some problems with exchange energy, electric energy into heat, the resistivity. But it is more safe and more expensive when we should transport value on long distance. But slowly we go to end of my talk, and it has some interesting materials, is so-called phase change materials. We know that some phase transition may become elected with endothermic or exothermic phase transition. Utilizing as a phenomena, we can storage heat in materials and release it very easy on demand. And here is some equipment or some commercial products which give us such opportunity. And also is used in our country, but in different way. We heating a system, put back into hot water, and after absorbing energy, we go on over phase, and when we release energy, when we have some push, etc. And next, I very fastly go to end of talk. It is also thermal energy storage, and you can, for example, storage thermal energy deep underground, for example, 3 meters in deep, temperature is lower than in comparison in surface, and also in our countries when we take heat from ground to winter, because in winter outside, and for example, when we use heat pump, we at source not use air from atmosphere, but also from heater up to +7 in underground. And here is also most important storage hydro electricity. It is working as follow when we have free energy from solar cells. We pumping water from cooker to higher tank, and utilizing such energy is very interesting. But we, for such system, we can use some moving of sea level, and in some place in England and in some Europe and Belgium and Poland, they have a natural time. And do the moon sea level grow, they fulfill a tank, they close, and went down when using for doing electricity in such system, because they need not need pumping up, because sea level grow and fulfill natural. But
example, utilizing or exchanging or storing electrical energy from photovoltaic, for example. When have a strong photovoltaic system, we can utilizing one electrical energy to supply pump, and we fulfill a top tank. And in night, when not have sun irradiation, we utilizing releasing hydral energy, and we have a generator which source of energy is
It's a many solution. I only fast the pass, you obtain my presentation, you find some information regarding a possible system, and even is when you don't like water, we can compress air, and we have a compressed air and have utilizing jak stream machine for preparing energy. And it is some system which index when we also when we compressing air, we producing heat, and when we collect such heat, and when release, when we when we can release air storage tank, we can utilize also such heat for heating and increasing the pressure of storage tanks. It's not important, but also is some final slide when we can see how specific energy may be stored in different systems. And it is interested because for particular application, when we need a strong power, we can use a different source of energy storage, but we have choose opportunity to choose a proper device when we need particular. Thank you for your attention. Nice.
Thank you, Professor Michael, for a wonderful lecture. Very informative and instructing regarding energy storage. Now the floor is open for discussion. If you have queries, you can ask. And it presents not only today's topic, the last 4 days. Yeah, so yeah, okay. Yeah, if no more questions, then we'll start the exam. Right?
So we'll start the program with national song. Please rise for the national song. So first we'll start with the feedback session. I request the participants to give your feedback regarding the course and regarding the stay and regarding the institute. So please.
So one by one. Otherwise, I will call you by name.
Yeah, so about the course and program, like this was my first time going to some NIT and attending some course. I've been to other IITs, but just for the project work, nothing else. But this was the first time learning from international faculty, especially led to on the theoretical physics subjects, which I was not exposed to before, as I'm from engineering background completely. So shortly, I learned many different things here, and especially the tutorial sessions where they explained us about the Solgel method, hydrothermal method of preparing nanocomposites. It was really very helpful for us. Thank you. And lastly, food and accommodation was also very good. Thank you.
Thank you. Any other participants, please?
Hi, myself Maran, coming from the Central University of Tamil Nadu. I'm a recent graduate. Recently, I have been participating in Gian courses like nanomaterials. It is one of my kind I'm attending, but it is very interesting to attend these kind of courses because I am aspiring to become a PhD student. So it is refreshing my lots of concepts and it is introducing me lots of theories and tutorials or experiments behind nanomaterials and everything and their applications also. And regarding this multifunction nanomaterials course, it is one of my interesting top research interest topics. So I am interested in energy storage. So I'll gain lot of information and I brushed up lot of concepts of energy storage and green energy conversions also. So I would like to embrace this opportunity in my future research field also. And regarding the institution, this is the first time I am visiting the NITs. Actually, I am from Tiruchi. I have visited NIT Tiruchi, but it is quite different from the NIT Tiruchi. I can see lots of difference and I can experience good food because since I am from Tamil Nadu, I can see the lots of difference in the food combinations. I really love the food they are provided, and the accommodation is also very good. Thank you for this opportunity for conducting this kind of Gian work. Thank you all.
Good morning to everyone. I'm Hansi and I'm from Trinity University, Bangalore. For me, the highlights of this course and coming here all the way from Bangalore was we got to learn about light, photovoltaics, and photonics by looking less at our screens, which we do all the time. That was the best part for me about this course and this whole program. And of course, the food and the accommodations were very nice. And yes, the information and things we learned was very informative, very interactive. It was really nice having somebody from the other side of the world have us teach things like this. And it was really, really, I would say, interesting to listen to people and their questions. Thank you. disadvantages, and what are the replacements we can do, and how we can work further on it. So first, what is kinetic energy harvesting? So we all know what kinetic energy is. So if we're using the kinetic energy, the technique of collecting energy from physical movements. For example, when you're walking, using the footsteps of your we can generate electricity, and also your physical movements when you're cycling or running or anything, any physical movement. So the vibration that you produce, generating electricity from that, we can convert it and use it to various technology. So first, what are the methods used? So basically there are three types of methods. One is piezoelectric generator, has a minus a thought about the piezoelectric patches. So we focus more on piezoelectric. So piezoelectric is basically a method where you generate voltage using pressure. For example, I take up an example here. So imagine that, I'll give an example. For example, okay, there are a lot of examples. There's a footpath. This technology is already equipped in Japan and China. So in India we don't have it. So if we implement it here, it will be more useful for us to produce electricity for footpaths or any other basic needs. So here you have two electrodes where if you step on the electrode, the piezoelectric pack or the material between it vibrates and deforms. When it deforms, it produces a vibration, and we collect that vibration, and then we use a capacitor to generate, we use a rectifier to generate electricity and store it using capacitor, and you can even use it to produce electricity for lights, fans or any other LEDs. So it converts mechanical pressure or bending load when we applied on the blade surface. So here the piezoelectric, to be more specific, it is PVDF and PZP. Since these are very harmful and they are very toxic, it contains lead, so it is very toxic. We will be using a different method for producing electricity in our country. So electromagnetic generators will be present. Good afternoon everyone. Once again I'll be explaining a little bit about the electromagnetic generators. We know that the electromagnetic generators work on a Faraday's law, which states that a magnetic field can induce a current, an electric current. This is basically what it works on. You can read on the screen as well, but if I were to explain it in more simpler terms, an electromagnetic generator basically consists of three parts. There is a magnet to induce the current, there is an armature or a coil, a shaft where the coils are going to be wrapped around, and then there is going to be a commutator, from where are you going to exactly sense that there is a field, or where you are going to take the current in from. This is basically it, and as Pavitra said, we are going to be replacing that piezoelectric thing with this specific apparatus. To read it again, electromagnetic generators, as I said before, come with three parts, and we would be dividing the efficiency, the same, not the same, but somewhat this, trying to replicate the efficiency of the piezoelectric patches with the electromagnetic generators. As I told you before, it was on the principle of electromagnetic induction. You can read mechanical motion from footsteps, vibration or rotation. That is basically the foundation of what we're planning to do. The main idea work or charge your small devices, or I like to think that even if you're just powering a bulb, I guess that can help somebody, or at least us. So I'll be telling about the advantages as well as the disadvantages, as a coin has two sides. The advantages for this is it is compact and light. You can see the material that I showed you is just this. So if you keep on the footsteps, it is very compact and light and low maintenance, because if you keep it once, when you fix it once to your footpath, you don't have to keep removing it or keep maintaining it again and again. and it's environmentally friendly in the case when you're producing it, you don't pollute the air, you don't produce anything. For example, using other electricity producing methods, for example, thermal production, we burn the coal where we use fuel, which is again a disadvantage for us, as well as we pollute the air, and the steam also, it is not that efficient. So it's environmentally friendly and instant response. As soon as you keep your steps or these electric patch vibrates, it generates electricity. Then disadvantages, as I said, even though if you generate electricity, it is not as much as liquid, but you can still generate electricity. For example, you can use it for LEDs, which doesn't require much light, and it's expensive. As I told, it's highly expensive. And durability issue, it is like if you keep, for example, if you, as Raghavendra sir said, India doesn't have any civic senses. If you place it at any footpaths or any local areas, people will not use it properly as we thought. So durability issues are there, and it also contains hazardous material. So it contains less, so it is very toxic in nature, and the disposal of it also contains a huge issue. So here ends our presentation. Thank you so much for your attention, and thank you, sir, for giving us this opportunity. Thank you so much.
Now I request all the dignitaries please come on the dais. So it's a good presentation. Coordinator Professor Abdul Azim to brief the about the 5 days program.
Very good afternoon to all. So finally we have reached the concluding session, the objective function of this 5-day GAN program on the multifunctional nanomaterials for lighting, photocatalysis, green energy conversion, and renewable applications. So the program started, initiated long back, and we got this GAN program sanctioned in the December last year. And on that day onwards, we started the advertisement of this particular program, guidance program, and then we got good response. So we got almost 57 people that registered, 47 through the Google form are circulated, and then 10 students are registered on spot. So total you have 57, and out of which 37 students from the different parts of the country, as they mentioned, the audience of the participants, few are from Tamil Nadu, few from Bangalore, right, and then few from Hyderabad and within Telangana, and remaining 22 from our NIT, from mechanical, from physics, and other departments. So it's a quite good response, and I would like to thank Dean International Relations and Revenue Affairs for the support that is extending from the beginning of the course, and I would like to thank our the foreign expert, Professor Michael Pinaski. So he came all the way from Poland, and so I have contact with him for last 12 years. I met him in 2011 in Vellore, PIT Vellore, during a conference. He is a accountant to one of my colleagues in Vellore, where I worked for 5 years. So thank you, Professor, for your valuable time here to spend and motivate our students, especially the first year students. So it is, I mean, a good feedback from us, and because of you, I mean, they are presented, and yesterday I think during interaction, so you came to know that these people are very much interested towards the latest technologies in the field of the energy generation, and you make them to present today. So thank you very much, and I thank our in charge HOD, Professor also, for present this particular validity function. So before going to conclude my speech, I would like to say that we during these 9 sessions of this 5 days workshop, there are 18 lectures, then 2 tutorial classes, and then 4 practical classes. So out of 18, 2 lectures delivered by Professor Michael Piaski on various topics which covers energy storage, photoluminescence, photocatalysis. So he has covered almost all our areas of physics. So that's why we have named this workshop as a multifunctional workshop, materials for multifunctional applications. So he has given 2 lectures, and myself and the other coordinator we have given 6 lectures, and he has given 2 tutorial classes, and then we have conducted lab sessions both for nanomaterials and nanocomposites in the physics and the mechanical engineering laboratories. So I would like to thank all the participants to make this event success. I thank all the colleagues from my department, colleagues from the other departments also. We are, present here in spite of the busy schedule. Thank you very much. Thank you one and all for making this function grand success.
From the last 4 days, we are continuously listening the lectures from Professor Michael Piaski. Now I request the professor to give this address in the valedictory program. Professor, please.
Dear participants, dear staff, it was a great pleasure for me and honor to be invited by Gian Commission to participate in teaching program for students from different places of India. As you know, topics which we consider belong to a very wide discipline of material science, chemistry, and physics. And my intention not was teaching you, but open mind on different topics. Sometimes, though some more light discussion, I would like show you some method of attempt to solve some scientific problem. And I would also would like to show how collaboration between teams and inside country, outside, improve in the form of synergy or science, and help us to solve up to now unsolved problems. For you, you came here and from different places, India, many famous scientific institutions and universities. And I hope such 1 week spent together in one dormitory, 2 dormitories, and one place also establish a personal contact, and you have collaborate in future and inform one another about interesting meeting, conference, etc. Maybe you have also opportunity to interest your professors, your supervisors to collaborate one with another. And I hope that my presence here maybe caused better, some better in your develop science. You are in like sun radiation in a wide spectrum in age. It is because from 17 up to 30, almost years old participants. It is also was difficult to choose a level of education because of experience of your is quite different. But I hope that participate in such one week course give a positive impact for input to your future science. And good luck, and maybe we have opportunity see again when you have any problems or like want to take advices, please send to me, and if you need some additional information, I also ready for helping you. Thank you again. And good luck. Thank you.
Professor Michael PSP, international expert of Gian program on multifunctional materials, nanomaterials for different applications, and local Gian coordinator and Dean IRA, Professor S. Srinivasarao, and coordinators of the workshop, Professor Abdul Azim and Professor Raghavendra, and my dear colleagues and participants from different places who participated for last 5 days in this program and making the program successful. On behalf of the HOD and Department of Physics, I congratulate the coordinators for successful completion of the program, and I also thank the participants for making this program successful, for presenting all the 5 days and learned many things. I hope you learned many things, many concepts about multifunctional materials for different applications. And I request all the participants to maintain this collaboration with international faculty as well as NIT Warangal, and especially Department of Physics. And thank you one and all for giving me this opportunity. Thank you.
Thank you, sir. Now I request Dean IRAA, Professor S. Srinivasarao, sir, to address the gathering.
Respected Professor Michael Piasky, coordinators of this 5-day Gian program, Professor Abdul Azim and Professor Raghavendra, in charge head of the department, Professor Aparo, and all other professors of physics department and other faculty members of the Institute NIT Warangal, and all dear participants who came from different parts of the country for attending this 5-day Gian course. I thank all the participants for showing interest to attend this 5-day program on these nanomaterials. And I also thank Professor Michael Piasky for showing interest to entertaining our faculty for submitting the Gian proposal. So that was the first step for getting for conducting this type of programs. So because of the contents and the strength and the expertise of the foreign faculty expertise and Indian coordinators, faculty coordinators expertise, course was approved by Government of India, the Gian scheme, and because of that we all are here, and a lot of knowledge exchange might have happened for these 5 days, and since Professor is available here physically, we might have interacted with him not only during the classwork time and after the classwork also you might have interacted and got a lot of exposure. This is a great opportunity provided by Government of India for bringing foreign faculty here and making interaction with all the Indian researchers, faculty members. It is a very great thing Government of India is doing, so we all should utilize this facility provided by Government of India, and this interaction not only supposed to stop at this 5-day interaction. You can interact with the professor through email for any of the doubts or for higher studies or to do MS programs in their country or PhD in their country or any other research collaborations. He is a very nice gentleman, speaks so nicely and entertains all of us for any of the small doubts we get in the subject. And he is very he is well known to many universities in our country. He told us that he used to visit our country so regularly, and he is such an international reputed person. So definitely you should make a further interaction with him. So this, regarding this course, the nanomaterials, these materials are used for many things, particularly if we will refer to the engineering applications, so electrical, mechanical and electronics engineering applications. These materials are very, very important. These nanomaterial technology, these materials have brought a lot of change, revolutionary changes in all the titles, whatever was written, lighting, green energy conversion, storage energy, and catalysts, etc. So we know that previously in the incandescent lamp for lighting applications, incandescent lamps were used and they are having only very less lumens per watt. 16 lumens only they are used, 16 to 20 lumens only they used to give light output for a consumption of 1 watt of electrical energy. So after that, what fluorescent tubes came and they gave some advantage. Lumens per watt is slightly increased. After that, is compact fluorescent lamps came to increase the lumen output. More amount of mercury was used in those lamps. And whatever technology we are going to develop, that should be satisfied by social, technical, economical, and environmental conditions. So one of the major failure of all these 4 aspects is then this compact fluorescent lamp. It came very quickly and it died very quickly because of mercury. So after that, this LED lamps came, semiconductor technology is improved a lot and materials efficiency was increased and LED lamps came, they are giving 300 lumens per watt. So 16 to 20 lumens per watt too, we came to now 300 lumens per watt. So that is due to the advancements in the material technology. Similarly, energy storage also. Previously, lead acid batteries were used. After that, nickel cadmium batteries came, and because of cadmium, some problems are there. They want to survive in the field. After that, magnesium sulfur batteries came, and they have some their own drawbacks. And then Jibra batteries came, and they have some other drawbacks. And now it was stabilized to some extent at lithium-ion batteries. The raw materials required are very rarely available throughout the country. Uniformly, they are not available. So we are supposed to depend for raw materials on some other countries, and they have to be refined and efficiency has to be increased. Like that, material technology is improving, and a lot of research is going on to give comforts and convenience for all of us throughout the world by making our life comfortable. So I thank the people who are working in this materials technology so that their contributions only made our life comfortable. Still further, the research should go on in this area, and so that lumens per output in the lighting and battery energy storage must be compact, and solar cells efficiency must be increased so that huge amount of electrical energy can be generated, so that all the thermal power stations throughout the world can be shut down. So we all know that thermal power stations, overall efficiency of thermal power station is only 35% efficiency. Efficiency is 35, but damages created by solar thermal power plants, so we cannot discuss now. We all know that they create a lot of environmental damage for the efficiency is very less. So it is high time for concentrate on the research on nanomaterials so that so total green energy generation or compact energy storage and lumens per watt in the lighting applications also will increase, and some semiconductor devices also can be developed. Now semiconductor devices are having so many drawbacks. Some devices operate at higher switching frequency, but they cannot handle more power. Some devices are operating at more power and operating at less switching frequencies. Still some research is required with reference to electronic devices, like a device should operate at higher switching frequencies and handle higher powers. So that is the target already set
that for the electronics engineering field. So material side, a lot of research is required to handle such type of things. So I thank all the professors who are actively involved in this research in material side in the Department of Physics and other departments in NIT Warangal. And I also thank Professor Michael for spending his whole life on doing research on the material side. Definitely his contributions will help throughout the world and make the life of the human beings more and more comfortable. I wish all the best to all of you. Thank you.
Now we have certificate distribution. After certificate distribution, we'll have a group photo. So after certificates, don't leave the hall. Please be seated. Lakshmi Priya. Pavitra. Sunil Prasad. Rajkumar. Saujanya. ML Saujanya. Pooja Yadav. Sushil. Mohan Suman.
Pathology. Solvent. ये महालक्ष्मी. अचल शर्मा. राजेश. शशिकांत. सुजी. अनिल कुमार. गोपीनाथ चौधरी. अखिल. एल्मा रोशनी. पी राजू. कृष्णकांत. कृष्णकांत. राजेश्वरी. महेश. So now I request Dean IRASR to give few certificates. Ramesh Kumar. Ramesh. Jam Ramesh. CH Sumalata. Ramu Ainala. Bikanuri Kumar. Dheeraj. Krina. Yuvraj. Mansi. B. Saujanya. Gangadhar. Satyanarayana. Akshay. Ramesh. Any other Ramesh? Daniel. Naresh. Gokula Naresh. Durga Prasad. Prasanna. Prasanna Vanapati. Narasaya. Devika. Angam Shaika. Shaika. Now I request Apollo sir, Mr. HOD to give you certificates. Naveen Kumar. Anil. Vanishri. Prem Swarup. Rohit. Lakshita. Rakesh. Yan Rakesh. Dev Prasad. Swalowchishrav. K. Rakesh. Now I request all the participants to have a group photo here. Please come under the dais.
Sorry. So it's a smile, right? Thank you. Bye.
and also thank all the and also thank all the and Kalam staff for arranging all the food and the necessary things for all the participants. Last, I'll thank all the participants who are coming from the different parts of India to attend this program. So, I'll like to thank our coordinators like Ajim sir and the head of the department, Professor Saurav Rai sir, for arranging all the things in time. So with this, I'll conclude this. Now, we have a grade sheets to distribution. Probably like as a time constraint, we are not giving the grade sheet now. After lunch, we are giving the grade sheet. Once evaluation is done, and then after that, we'll distribute the grade sheets. Now I request everyone to rise for national anthem.